Hi, I'm Seth from the DataRobot Product team. In this video, I'll show you how to pull a custom hand-coded model from your Bitbucket Server Repository, allocate resources for it, and test it before deployment using DataRobot MLOps. Let's assume that my model is located in my team's Bitbucket Server Repository, as shown here. We have our pickled model as well as code to load it with our custom.py file. Before pulling these artifacts into MLOps from Bitbucket, we'll need to make sure that our Bitbucket server repository is registered. We can see here that we have several repositories registered, but it looks like we don't yet have our Bitbucket server added. So let's add that now. We'll do this by providing user access token. And this will provide direct access to the Bitbucket server. Once added, we'll test that the server is able to communicate between DataRobot, and then users will have a direct transfer between their code control, in this case, Bitbucket server, and their governed source for MLOps, in this case, DataRobot. Now that we've added the repository, we'll continue to assemble our model for deployment by adding our modeling artifacts directly from Bitbucket using this integration. Here, we'll enter a tag or a branch or a commit hash to pull from the repository. And next, we'll specify the path that the model artifacts, where the model artifacts are that we want to include. Once assembled, we'll be able to either deploy our model directly, test that our model is robust and able to handle production traffic, or add this model to our registry. And this overlaps with another feature that we've recently added with the DataRobot 7.0 release, and that is the custom model resource management. With the custom model resource management, administrators are able to set maximum limits for custom model resources used across the organization. And at deployment or at testing time, users can set resources up to these defined limits. In this case, we have maximum of 4 GB of memory to allocate, or up to 4 replicas for each use case. And this is to provide that opportunity for high availability in your Kubernetes instance. Once the model is successfully tested, we'll have evidence of its robustness, able to handle new unseen data, and have the added confidence that our model is able to handle that production data. Thanks for watching.